So the second problem which we have in hand is also a very fundamental problem of this chapter and also very important because it is a problem of Raoult's law. We are given that a solution of a non-volatile solute in water freezes at minus 0.3 degrees Celsius. The vapor pressure of pure water is 23.51 millimeters of mercury and Kf for water is given. We need to calculate the vapor pressure of this solution at 298 Kelvin. Now what happens? There is a pure solvent, water present over here, and we know that water freezes at 0 degrees Celsius. But when this solute, this non-volatile solute is added to this pure solvent water, there is a lowering of vapor pressure of water. And the new vapor pressure, it is given that this solution freezes at minus 0.3 degrees Celsius. Vapor pressure of water is given to be 23.51 millimeters of mercury, and we need to find the new vapor pressure of the entire solution, which is comprising of water as well as this non-volatile solute. So by Raoult's law, we know that relative lowering of vapor pressure is equal to mole fraction of the solute This is the general statement of the Raoult's law, that is, the relative lowering of vapor pressure on addition of the solute in the pure solvent is equal to the mole fraction of the solute. If we assume the vapor pressure of pure solvent to be equal to P naught and the new vapor pressure for the entire solution to be equal to Ps, then by Raoult's law we can write P naught minus Ps upon Ps is equal to moles of solute upon moles of solvent. Also in the problem, we are given with the fact that the new solution freezes at minus 0.3 degrees Celsius and earlier there was water which freezes at 0 degrees Celsius. So there is lowering or depression of freezing point by 0.3 degrees Celsius, and this we know is equal to Kf of water into molality of the solution. So we can find out the molality to be equal to 0.3 divided by Kf, which is equal to 1.86. Hence our molality is 0.3 divided by 1.86, which is equal to 0.161. On putting the values in this formula, we know that P naught is equal to 23.51, which is given in the problem, that the vapor pressure of pure solvent water is 23.51 millimeters of mercury. We want to find the new vapor pressure Ps divided by Ps is equal to moles of solute divided by moles of solvent. So what we can do is, we can divide and multiply mass of solvent in kilograms so that this gets converted into molality, because we know that molality is equal to moles of solute divided by mass of solvent in kilograms. Divided by moles of solvent. Our molality is 0.161, so this becomes 23.51 minus Ps upon Ps. This becomes molality, which was 0.161. This is mass of solvent in grams divided by 1000, and this This moles of solvent can be written as mass of solvent in grams upon the molecular weight of the solvent, and here we know that the solvent is water, so this becomes 18. This mass of solvent and this mass of solvent gets cancelled, and we get the equation 23.51 minus PS upon PS is equal to 0.161 into 18 upon 1000. On solving this equation, we get the value of PS to be equal to 23.44 millimeters of mercury. So hence here we can see that earlier the vapor pressure of water was 23.51 millimeters of mercury, and there is a lowering of vapor pressure on the addition of solute in the solvent, and the lowering and the new vapor pressure of the solution is 23.44 millimeters of mercury. In this question we applied the general formula of the Raoult's law and hence obtained the final answer as 23.44 millimeters mercury as the final vapor pressure of the solution.